Today we're going to talk about basic concepts of complex numbers. Now, if you recall, complex numbers are those numbers that come from this idea that x squared equals a negative number. In our regular number system, we can't deal with x squared equals a negative number. But the complex numbers allows us to think of x then as equal to the square root of -1. What that means is that I has a value. We call that I. It's defined as I squared equals -1, which means I is equal to the square root of -1. Here's some examples of how we can use that. When you have the square root of negative number, you think of the negative number as the product of the square root of -1 times the square root of 16 in this case, and we get I times 4, or 4i. Over here, we have the square root of -1 times the square root of 70. So I have I times, well, if we think about the factors of 70, we get 7 and 10. It turns out that 70 can't be simplified. So this is simply I square root of 70. The square root of 48 turns into -1 times 48, the square root of both of those. So I have I. 48 is the same as 16 times 3. 16 is 4 times 4, so I've got two of a kind there. So I times 4 times the square root of 3, or 4i square root of 3. Now you have to be careful multiplying. Don't multiply first. Take the negatives out. Deal with the negative first. If I multiply -4 times -9, I get a positive 36, which gives me a square root of positive 6. However, if I deal with the negatives first, I get a different answer. This would give me 2i times 3i. Well, 2 times 3 is 6. I times I is I squared, which has a value of -1. So always take the i's out first. Deal with the negatives first. Don't multiply first. And here's what we mean by this. This is going to turn into I square root of 7 times I square root of 7. So I squared on the outside, 7 times 7 on the inside. So -1 times the square root of 49, or -7. Square root of -6 times the square root of -10. Well, I square root of 6 times I square root of 10 gives me I squared on the outside and 60 on the inside. 60 is the same as 4 times 15. So now I have an I squared on the outside, which is a -1. I can take a 2 because I've got two of a kind there, and I'm left with 15. So if you don't take care of the negatives first, you end up losing track of some negatives. And you want to do the same thing with the division problems. That's I over the square root of 20, I over the square root of 2. Now I can notice the i's cancel, and I can turn that into a big old fraction here, and that gives me the square root of 10. So you may get the same answer if you don't deal with the negatives first, but sometimes you don't. So it's always best to deal with the negatives first. So here I have I squared 48, square root of 48, over the square root of 24. Now, since I have all the negatives out from under the root, I can do what I've been doing on these square roots. 48 over 24 is 2, so I get I square root of 2 there. Writing in standard form, what that means is we're going to put the plain old number part, the real number part first, and then we're going to follow that by the imaginary or the complex part first. So first of all, I split it up into two parts and get -2. Now I can't simplify a number underneath and a number outside. So 128 is the same as 64 times 2. 64 is the same as 8 times 8. So I have I times 8 times the square root of 2 over 4. Now, since this is an outside 8, and that's an